Hello, students! Have you ever wondered what happens to all the atoms during a chemical reaction? I mean, where do they go? Do they just vanish? Well, today, we're going to solve that very mystery. We are going to learn how to balance chemical equations. Now, I know this can seem a bit tricky, but it's a really important skill in chemistry. And I promise you, by the end of our session today, you'll feel so much more confident about it. So here's what we have planned for today. First, we'll look at what a balanced equation actually is. Then we'll talk about a very important rule, the law of conservation. After that, we'll get into the main part, the hit and trial method, with a couple of good examples. We'll do one about iron and steam, and another with magnesium and oxygen. And finally, we'll wrap it all up with a quick summary and see what's coming up next. All right, let's start with a little puzzle. A skeletal chemical equation. It's a bit like an incomplete recipe. It tells you the ingredients, what we call the reactants, and it tells you what you're making, the final dish, which we call the products. But it doesn't tell you how much of each ingredient to use. So our job today is to figure out those missing amounts. I'm sure you remember this from your science lab, that bright, dazzling white light when a magnesium ribbon is burnt. That's exactly the reaction we're looking at here. So on the left, you can see we have magnesium, Mg, plus oxygen, O2. Those are our reactants. And on the right, they combine to give us magnesium oxide, MgO, our product. But is this equation really complete? Is it telling us the whole story? Okay, let's become detectives for a moment and check the atoms. So on the left side, the reactant side, we have one atom of magnesium, that's Mg. And we have two atoms of oxygen, O2. Got it? Now look at the right side, the product side. We have one atom of magnesium, but wait a second. How many oxygen atoms do you see? Only one. It looks like one of our oxygen atoms has just disappeared. But can that really happen in chemistry? Well, that missing oxygen atom is actually a very big deal, a huge problem in fact. Why? Because in chemistry, in the entire universe, atoms just can't vanish into thin air. There's a fundamental rule, a universal law that they have to follow. Let's find out what that is. And that universal rule is called the law of conservation of mass. It's really the golden rule of all of chemistry. And it simply says that mass can neither be created nor destroyed in a chemical reaction. So what you start with, you must end with. Matter can't just be made from nothing or disappear. It only changes from one form to another. Let me give you a simple example. Think about cooking something in the kitchen. Let's say you're making a dish. If you take all your ingredients and weigh them before you start cooking, and then you weigh the final dish you have prepared, the weight must be the same, right? Nothing just disappears. Well, it's the exact same idea with atoms in a chemical reaction. The atoms are your ingredients. So, what does this mean for our chemical equations? It means that to obey this law, the number of atoms of each element must be exactly equal on both sides of that arrow. The reactant side and the product side must match. So, balancing an equation is really just our way of counting the atoms to make sure none have been created and none have been lost. Okay, so how do we actually do this? How do we balance an equation? We are going to learn a method called the hit and trial method. Now, the name sounds a bit like you're just guessing, but it's not really guessing. It's more like solving a logical puzzle, step by step. And with a little bit of practice, believe me, you'll get very good at it. Now, before we start balancing, I need you to remember one rule. This is the most important rule of all. Please listen carefully. You can change the numbers in front of a chemical formula. We call these the coefficients. But you can never, and I mean never, change the small numbers inside the formula, the subscripts. For example, take water, H2O. You can put a big 2 in front to make it 2H2O. That just means you have 2 molecules of water. But you cannot change the formula to H2O2. Why not? Because H2O is water, but H2O2 is hydrogen peroxide. It's a completely different chemical. Changing the subscript changes the substance itself. This is a very, very common mistake students make in exams, so please remember this rule. All right, are you ready to try our first example? Let's take the reaction of iron with steam. This is a classic one. We'll go through it together, step by step. Don't worry, I'll guide you. Okay, first step is always to list down the number of atoms on both sides. Let's make a small table. On the left-hand side, the reactants, we have one Fe, that's iron, we have two H, hydrogen atoms, and one O, oxygen atom. Simple enough? Now, for the right-hand side, the products,
We have 3 iron atoms, Fe3. We have 2 hydrogen atoms, H2, and 4 oxygen atoms, O4. As you can see, the numbers don't match at all. So let's start balancing.
Now here is a helpful tip to make this easier. It's always a good idea to start with the compound that looks the most complex, the one with the most atoms. In our equation, that is Fe3O4, okay? And inside that compound, let's focus on the element with the highest number of atoms. Here, it's oxygen. We have 4 oxygen atoms. So let's try to balance the oxygen first. We have 4 on the right, but only 1 on the left. So what do? To make the oxygen atoms on the left equal to 4, we need to put a coefficient of 4 in front of the entire H2O molecule. So now our equation has 4H2O. And great, our oxygen is now balanced, 4 on the left and 4 on the right. But wait, when we did that, we also changed the number of hydrogen atoms, didn't we? Now we have 4 times 2, that's 8 hydrogen atoms on the left, and still only 2 on the right. See how one change affects another? That's part of the puzzle. Don't worry, this is normal. We just have to fix the next thing. We've balanced oxygen, so let's move on to hydrogen now. Just take it one element at a time. So we have 8 hydrogens on the left, and we need 8 on the right. On the right side, we have H2. To make it 8, what number should we put in front? That's right, a 4, because 4 times 2 is 8. So we put a 4 in front of H2. Perfect! Now our hydrogen is also balanced. We have 8 on both sides. We're getting close. Only one element is left. And the last step, the final element, is iron, Fe. This should be the easiest one. Okay, on the right side, we have 3 iron atoms in Fe3O4. On the left, we only have 1. So, to balance it, we just need to place a 3 in front of the Fe on the reactant side. And we are done. Let's do a final check. 3 iron on the left, 3 on the right, 8 hydrogen on the left, 8 on the right, 4 oxygen on the left, 4 on the right. Everything is perfectly balanced. See? Every atom is accounted for. That was excellent. Now that you've seen how it works, let's do one more, slightly simpler example to practice. Let's go back to that burning magnesium ribbon reaction we saw at the beginning. Let's balance that equation properly now.
So, here's our skeletal equation again. Mg plus O2 gives MgO. Let's do a quick count. 1 Mg on the left, 1 on the right. Okay, 2 O on the left, but only 1 O on the right. That's our problem right there. We need to fix the oxygen.
Okay, to get 2 oxygen atoms on the product side, what do? We put a coefficient of 2 in front of MgO. Remember, we can't change it to MgO2. So now we have 2 MgO. This gives us 2 oxygen atoms, which is great, but now we have 2 magnesium atoms on the right side. So to fix that, we just go to the left side and put a 2 in front of Mg. And that's it. Let's check. 2 Mg on the left, 2 on the right, 2 O on the left, 2 on the right. Balance. You see? Once you follow the steps, this hit and trial method is actually quite straightforward. Let's just quickly summarize the process so you can remember it for any equation you face. So, here are the steps to remember. First, always write down the unbalanced skeletal equation and list the atoms on each side. Step 2, it's usually easiest to start with the most complicated-looking compound. Step 3, balance the elements one by changing the coefficients, those big numbers in front. And step 4, the most important rule again, never change the chemical formula, the small subscript numbers. And finally, step 5. Once you think you're done, always do a final check to make sure the atoms of every single element are equal on both sides. If you follow these 5 steps, you'll be able to solve any of these balancing puzzles. So there you have it. You now know the secret to balancing chemical equations. Well done. But our journey into writing proper chemical equations isn't quite over. A balanced equation is great, but we can make it even more informative. How? Well, that's what we'll cover next time, when we learn how to add the physical states of the reactants and products. So keep practicing what you learned today, stay curious, and I'll see you in the next session.